All right, we want to talk about light next, but we can't talk about light until we talk about radiation, because light is a subcategory of radiation. Now, we've talked a little bit about radiation. It is an energy transfer, and it is an energy transfer that involves waves. So let's talk about waves. Waves have a quality called a wavelength. And what this wavelength measures is the distance between one point in the wave and the next identical point in the wave. So you can measure it from trough to trough. Oh, I'm sorry, these were crests. You can measure it from crest to crest, or you can measure it from trough to trough, or you can have this point where it's descending to the next point where it's descending. As long as you're picking two identical parts, you can measure the wavelength, and the wavelength will be the same throughout that wave. Well, waves can have different wavelengths. So, for instance, this one has a very long wavelength, the distance from here to here, and this one has a shorter wavelength from here to here. So many more cycles of this wave repeat themselves within the same distance. So here you've got 5 cycles, and here you only have 1 cycle. Well, there is an inverse relationship between wavelengths and energy. Inverse relationship means they're flipped. It's an opposite sort of pattern. So as the wavelength gets longer, the energy of that wave decreases. As the wavelength is shorter, the energy of that wave increases. So we can look at these wavelengths and tell you that the red wave here is going to have less energy than the blue wave here. Well, when we start talking about light, light is unique. It's a subcategory of radiation that we can see. Most radiation is invisible to us, and this room is filled with it because there's all different types of radiation, and a lot of it is invisible and a lot of it is safe, and it doesn't harm us. But light we can see. Light's wavelengths are in this range of between about 380 and about 750 nanometers. So what does that mean? What's a nanometer? So right here we've got this oh, here, you can't see any of that. Right here we got this ruler here. It's upside down, but you can see those little tiny notches. Those are millimeters. That means you get 1,000 of those, and that gives you one of these, a meter. You get 1,000 of those, you get a meter. Well, a nanometer is to take one of these and divide it into a billion pieces. So that would be taking this space right here, this tiny little notch between these two, between those two, divided by 1,000,000. If you divide that by 1,000,000, you will have a nanometer. And then if you take about 400 of those, that would be the size of the wavelength of violet light. So that's tiny, right? You take one of those, divide it by 1,000,000,000, and then take 450 little pieces. Super tiny, super tiny. Okay, so what do we need to discuss next? Oh, we got to discuss how this happens. How does light happen in the first place? Where does that light come from? We got these waves. Well, that has to do with atoms, because this is a chemistry class, so it's always going to have to do with atoms. So we've got an atom. And that atom's got a nucleus, and that nucleus has electrons that are, ziggle-zaggling around that nucleus. Well, if energy gets transferred to those electrons, they're going to have the power to break free from the pull of that nucleus. Because that nucleus is pulling them in, because that nucleus has got a positive charge, the electrons have a negative charge, they're being pulled in, right? This little guy, this little electron is being pulled into this mighty nucleus, right? But if we give it energy, well then, when it's moving around, it's going to be able to move around farther away. But that's not going to last forever. It's going to end up returning to its ground state. This is sort of like where its comfortable balance is between being pulled by the protons and being repelled by other electrons, and its constant movement. So it's going to have this ground state. And so it gets energy, and then it relaxes back to its original position. And when it does that, it releases energy. And that energy that it releases, that is light. So how do we make light? We give energy to an electron. It moves away from the nucleus. It moves away from the protons. And then it relaxes and returns to the protons. To relax, it's got to release energy. That energy leaves as light, which travels as that wave with some kind of wavelength. The longer the electron travels, back down to the nucleus, the more energy it's releasing. And if it's releasing more energy, then you're going to have a little tiny wavelength, and you're going to have a darker color, like purple. If the electron, if we've got the nucleus here, and the electron gets a little bit of energy, and then it comes back down, well, it just releases a little bit of energy, which means the light that it releases is not going to have a lot of energy, which means it's going to have a long wavelength, and it's going to have a warmer color, like red. And there you have it. I hope this helps. Struggle well.